Hi everyone, my name is Kurt Dusek. I'm a solutions architect with GitLab. In today's partner technical bootcamp video, we're going to be talking about AutoDevOps. AutoDevOps provides a predefined CI/CD configuration, and that will allow you to automatically detect, build, test, deploy, and monitor your applications that are hosted in GitLab. You can instantly take advantage of best practice approaches to CI, and it's a great starting point for your legacy applications, and it avoids starting from a blank page. So we can instantly modernize your application, and we can containerize it, scan it, deploy it, and monitor it all in production. Now, taking advantage of the monitor and review stages do require Kubernetes, and otherwise, AutoDevOps is available for all tiers, including core and free. However, certain features such as security scans will only be available at the paid tiers. Now, AutoDevOps is enabled by default, and we have the option to automatically deploy to production, do a phased deployment, or hold for a manual deployment. Now, beyond that, we can configure the specific stages and jobs of AutoDevOps via environment variables, and we can set those directly within the GitLab application. AutoDevOps at its core is a template file, and we can modify that directly. So to get a copy of this, we can use the web IDE within the GitLab app and go to the templates dropdown to get easy access to the raw AutoDevOps file for customizing. Everything in GitLab CI starts with a YAML file, and that is a declarative configuration format we use to define jobs and the rules for triggering those jobs. Now, the GitLab CI file lives within the repository itself. Now, this may be a bit different from other CI systems where the CI and CD platform is housed and executes in a separate system. Our belief is that for something to be true DevOps, that the developers and operators should be as close together as possible. And so this really allows those groups to work together by making changes and decisions by working in the same repository, or at least in the same application. Within this same system, we can also potentially avoid unannounced breaking changes, and that can catch teams off guard and generally cause problems. What we're looking at here is a sample CI file. And as I mentioned before, GitLab CI is very feature-rich, so we won't get into all of the capabilities today. The name of this file is always going to be .gitlab-ci.yml. That's a reserved name, and it sits at the root level of a project, and GitLab knows to read that file on every commit and apply the appropriate jobs based on the rules defined in that file. So what we see here is a very simple job. Each job is a unit of work. It has several components, like the name of the Docker image and the commands that will be run in that Docker image. Docker is a first-class citizen within GitLab CI, and you don't have to use it, but it's very handy for portability and consistency. And what you see here is actually a valid CI file. If we took these 4 lines and put them in a file, it would work. It's really that easy, and it doesn't take that much to get up and running. Here's a slightly more advanced job. It's called compile, and it specifies the stages it should be run in. Stages basically give you an order of operations to run your jobs in. We've also defined some conditions under which this job should be run, and some artifacts that will be generated that we may want to use later. Now, in this case, this is just an overview. We're not going to be going into conditions and artifacts as part of this video, but I just want to show something slightly more advanced. A pipeline is multiple stages that run in sequence, and you define each stage as a list in the order you'd like them to run. Then within your job, you can define which stage the job should be executed in. We can also include various files within our GitLab CI file, and this is a very useful feature. We can include from other projects, remote locations, or CI files that have come bundled within GitLab. You can even create a separate Git repository just for CI files and reference them from other projects. This comes in handy when you're wanting to keep automation centralized and consistent across a large organization. Here, we're referencing the included SAST CI file, which enables static application security scanning on our jobs automatically. Rules give us conditional behavior. In this case, I've added an if statement that triggers the job only if we're in a merge request. Here we have an AutoDevOps CI pipeline. You'll see a build stage, multiple tests and scans being run, a review app being deployed, DAST scan, performance scan, and even additional jobs that we can't see here. This is all generated automatically, as we'll see in the future lab. YAML and this approach to CI may be new for you. In addition to the CI files that come bundled with your installation of GitLab, we also host many example CI files and repositories on gitlab.com. And these files are open for you to use in your own projects or even contribute back to. We have a page that links to many of these repos in our documentation, and it's a great starting point depending on your programming language, the infrastructure you deploy to, or your security concerns. So with very little effort, you can have a CI pipeline that automates many of your tedious tasks. The merge request screen will probably be the most common place you'll utilize pipelines. On each commit that triggers a new pipeline, the merge request screen updates to show that pipeline and gives visibility into the status of each job. Typically, the same pipeline is run after the merge is complete just to ensure quality and verify the outcome of the merged branch. So, the natural progression from continuous integration is continuous deployment, and deployment of environments are first-class citizens within GitLab. This makes it easy to monitor, manage, and connect to terminal of various environments. Here, I can see 2 running environments, a production and a staging, as well as health statuses of pods within that deployment. This is a pipeline log, and it shows the history of pipelines that have run within this project. From here, you can view the details on what specific pipelines were triggered and their status. You can also re-trigger and download artifacts, as well as view the log or other details. The configurable operations dashboard is very useful for managers or DevOps engineers to get an at-a-glance view of pipelines and their statuses from various projects. This report can also be customized to show details on different projects across an entire group. Kubernetes is a huge part of GitLab. Just like Docker, it's a first-class citizen. If you're running workloads on Kubernetes regardless of cloud provider, you'll be able to easily take advantage of more advanced features of GitLab. It's also very easy to deploy commonly used apps like Nginx Ingress, Cert Manager, or Prometheus straight from the UI. The integration works with existing clusters or will provision new clusters on Amazon EKS or Google GKE. It's really just a matter of entering the credentials to get connected almost instantly. And this allows your organization to get started using Kubernetes very quickly. We discussed having review apps, and those were used for dynamic scans and performance testing. And it's common that those review apps might need a database or a Redis storage. And if you had a large number of review apps, that would be a very useful scenario for utilizing Kubernetes. So if you're not using Kubernetes as part of your production environment, you can still use it for review apps and for staging environments, and still take advantage of some very useful management features to streamline those efforts. So if you're new to CI or just new to GitLab and want to take advantage of many of the capabilities quickly, you can utilize AutoDevOps. This is best used for database-driven web apps running Ruby on Rails, Django, Node.js, or similar. To get started, you only need to connect to your Kubernetes cluster, ensure AutoDevOps is enabled in your project, and add code to your repository. AutoDevOps will containerize your application via Docker, run any existing unit and integration tests, perform code scans, security, license scans, and provision a review app. It'll also handle deployments and more without you having to write any automation. It's pretty cool. Now, let's get into our lab 2, AutoDevOps.